Alright, look at this crazy shape right here. What in the world's that thing? Well, basically, I put them in separate colors because it's basically three separate things, but we're finding the area of the whole thing. So what I did right off the bat was separate them. If you look in the book, though, they might have it all like globbed together in one color. So it might look more like, can you remember the colors of these? It may look more like, actually, let's do it like this. It might look like something like that, and that. Oops. Oh, goodness. Hang on.
Are you not doing section 11?
Alright, that looks a little bit better. We did section 11.3 Friday. Alright, so here's section 11.4. This is what it may look like in the book. It'll look more something like this. Now, I made them different colors just to kind of, make them stand out a little bit to you. And let's see if I can, let's see if I can do it again. What do we go to the paint thing? Alright, so let's make this red. This triangle is what? Purple, I think. And this was blue. Alright, good. Oh. Dumb. Let me try this. Oh, goodness gracious. Alright, now I finally got it. And now let's work with this. Let's put some stuff in here that they tell us about about the sizes of this figure right here. Let's get back to the page. It's on page 794 if you want to follow along. This little diagonal right here is 5.7. Let's make that a little thinner. So this right here is 5.7. This one down the bottom is 4. This height of the blue one is 7. And then from this center right here all the way to the end is also 4. Alright, this is the information that they give you, and you want to find the total area of this thing. Alright, you follow me? So let's do a little bit at a time. 794. So which one do you want to pick? Doesn't matter. You want to pick the semicircle, and that's a semicircle, right? It's not a whole entire circle. It's half of a circle, so it's a semicircle. We have a what? What's the purple thing? Triangle. And what's the blue thing? It's a rectangle, okay? Which one do you want to do first? Let's do the easiest one first. Let's do rectangle, since nobody's answering me. So the area, I'll put a little R there for rectangle. The area of the rectangle, how do we find the area of that rectangle? Pretty easy. 7 times 4, right. So it's 7 times 4 equals 28. And let's see, it's in feet. If you want to put feet squared, that's fine. I won't mark off if you don't. So 28 feet squared. That's not the total area, though, obviously. Okay, I'm just going to circle it just to kind of hold on to it. We'll use that a little bit later. What's the next one? Let's do the semicircle. That's not too hard. So it's a semicircle. We'll put SC for semicircle, which is a half of a circle. So what's a whole circle? What's the area of a whole circle? The area of a whole circle. It's pi r squared. Okay? Didn't we just learn that? Pi r squared. But this is half a circle, so what do you think we're going to do to it? Divided by 2. All right? Tell you what. Let's replace that r with what the r actually is. What is the radius of that thing? It's 4, isn't it? So it's 4 squared. So we can rewrite this, just simplify it a little bit. 4 squared is what? 16 divided by 2 is 8, and so that's 8 pi. Now, that's not my final answer. Probably shouldn't even circle it. We're just hanging on to it for a second. What are we going to do with all 3 of these once we're all finished? Just add them all up. That's right. To find the total area, we're just going to add all 3 of these up. This is one that's a little bit more difficult. It's the area of this triangle. Now, what do they tell you of this triangle? Well, they tell you one of the sides of the triangle is 4. Okay, I guess you kind of have to make a little assumption that's a right triangle. They don't tell you this thing right here, but they tell you the hypotenuse of that right triangle. Is there any way? Is it like half of this? Is it like 3.5? Or is it... No, there's really no way to see where this actually hits here. But it's a right triangle. I got 2 sides. That's all I need, isn't it? What can I do to find the third side? Pythagorean theorem. So let's do it. So it's going to be 5.7 squared equals 4 squared plus, what are you going to call this? X, okay? X squared. Now let's get x by itself. So x squared equals, subtract a 4 squared from both sides, so I'm going to get 5.7 squared minus 4 squared. What do we do with this squared right here? Square root it. Somebody want to throw that in a calculator? We did it in the last class. I think it was around 4.1. You want to just double check on that? 5.7 squared minus 4 squared, take the square root, and I believe that's it. Is that right? Okay. So we could have called it h also for height, because what do we want to do? Why in the world did we care about what that length was? Because we want to find the area of this little triangle here. So the area of the triangle, let's do that. So the area of the triangle is base times height divided by 2. So it's base, which is, actually, it doesn't matter which one you use. 4.1 and 4 divided by 2, right? That's the area of the triangle. Let's see if we can do this in our head without punching this in a calculator. All right, get used to that. 2 goes into 4 how many times? Twice. Multiply 2 times 4.1. What do you get? 8.2. Not hard, right? Start trying to do stuff in your head if you can. I know you can't always. I mean, there's a million times where I use the calculator, but little easy stuff like that you should be able to do in your head. So look what we have. We've got the triangle, we've got the semicircle, we've got the rectangle. What do we do to them all? Let's add them all up. So the total area, let's write it down. Now you could figure out what 8 times pi is if you wanted to, but I'm just going to write it down as 8 pi. You can just chuck that in a calculator when we do this. Plus the 28, that's the rectangle, plus the triangle, which is 8.2. And hopefully, when you throw all that into a calculator, you get about 61.3. Somebody try that just to make sure we're doing it right. It's in feet, so it's total area, so it's feet squared. There's your answer. Technically, this should be approximately, but I don't care if you put equals there or not. That's it. That's how you find the area of the whole entire thing. Break them up into their little sections, and then once you find the area of all the sections, then you just add them all up, and then you're done. As simple as that. Not too hard, is it? All right. Let's try something a little bit different. All right, now here's a little bit of a different thing. Okay, this is a new area. We learned how to find the area. Let's go through it. We learned how to find the area of what was the first thing? Like parallelograms, right? Just base times height. Rectangles the same way. Squares the same way. Base times height. Then we learned what? Trapezoid, right? It's let's go triangle first. I'll wait till everybody's paying attention. Thank you. We did a trapezoid, which is 1/2 the sum of the bases times the height. Then we did a triangle, which is just 1/2 the base times the height. Then we did a circle, which is pi r squared. Did we leave anything out? I think that kind of covers everything. What did we do? The height? The kite. Yeah, the kite. Good. If you didn't know all the other stuff in there, what was it? 1/2 times the product of the diagonals, right? D1 times D2. Good. So I think that covers everything. Rhombus was the same thing. But now this is a little bit different. This is a regular. Now this only works when they're regular. Oh, I always forget to do that. What does it mean? Again, I know I asked you earlier, but what does it mean to be a regular polygon? All the sides and the angles are equal to each other. Okay, all the angles are the same and all the sides are the same. Regular. Okay, polygon. Alright, so that means all 5 of these, there's 5 sides, all 5 sides are equal and every angle in there is equal as well. I'm going to introduce another word. Here it is. It's apothem. I think that's how you pronounce it. I don't know if I've heard any other teacher pronounce it. I just see it in the book and I pronounce it like that, so I guess that's how you pronounce it. Now, what in the world is the apothem? Well, I'm glad you asked. Watch. The apothem, this little dot right there, it's not just any arbitrary dot. What do you think is true about this dot? This dot is in the, we don't say middle, we say center. Okay, now, in order to be to the center, now watch, if I drew a line from here to here, look, that's different than there to there, isn't it? So, it's not the, see, watch, it gets longer and longer when you get to the points. So basically what it is that distance right there is the same as from that center to the vertices. Do you follow me? Okay, so that distance is all exactly the same right there. That's not the apothem. This is the apothem. The apothem is the perpendicular distance from the center of this regular polygon to any of the sides. I can pick any of the sides, all right? And I just picked this one down the bottom. It's just a little easier to see. All right, you okay with that? That's called the apothem, and we'll just call that A. Now, we're going to, let me see what they do here. Let's talk about, well, here's another thing we're going to use, and we'll go with the example here in a second. But watch, here's another thing that you're going to see would be this right here and this right here. Now, if you look in the book, they talk about a circle. If this was circle, or if this circle a circle was circumscribed about this polygon right here, the circle would hit here and here. This would be the radius of the circle, wouldn't it? Okay, if it was a circle going around this whole thing, touching at each vertex. But what I want to see right here is this. I want to talk about this angle right there. Now, if I drew these things out, I know I'm running out of time, just make sure I don't go over. Watch, if I drew this like so, tell me something about the angles. Tell me about this one, this one, this one, and this one. They're all equal to each other. How do I find each one if they're all equal to each other? I take 360 divided by what? How many angles that I have? How many angles do I have? 5. What's 360 divided by 5? Quick, hurry before my time runs out.
72.
72? Alright, so each one is 72 degrees. Let's go to the next video.